this is an unusual title to come to. I don't know how many people have heard of the JAMstack already? How many people have never heard of it and they just wanted somewhere to sit? Okay, bless you for your honesty. I'll try and unpack exactly what that is and make a little bit more sense of it. But you're probably already thinking, well, there are lots of stacks. You know, I've been developing for the web for a while, thank you very much, and there are lots of different web stacks. Why on earth would we need another one? Let me see if I can. Oh, I can't get my. Hang on 1 second. There we go. So, you know, why on earth would we need this other one, and why has it got such a silly name? Well, JAMstack stands for JavaScript, APIs, and markup. And is that clear now? Does that make perfect sense? Of course it doesn't. What on earth does that even mean? I will try and get into that, and I will try along the course of this 45 minutes or so to try and kind of break into that definition and try and get to a point of understanding so this kind of makes sense. I want to describe some of the impact this stack can make and talk about some of the opportunities that are there. Along the way, I'll describe some of the tools that exist and some of the services we might leverage using this kind of a stack. And to do that, I'll poke around in a few examples and talk about 1 or 2 results as well. But if anyone has heard of this stack before, they might be thinking of this. They might be thinking, isn't this just a fancy new name for static sites? Kind of, but not exactly. So I want to get into that and really get under the covers of what this thing is. My name's Phil Hawksworth, and I work in the developer experience team at Netlify. We'll hopefully have some time for Q&A at the end, but if we don't have time for Q&A, or if a question comes up later that you wish you'd asked, you can always ask me on Twitter or ask me around and about. I'm at the conference all day today, and we'll try and figure that out. So please don't be shy of asking questions later on. But this question we just started off with, isn't this just a fancy new name for static sites? Well, let's get into some definitions, and let's dig, first of all, into that word that was kind of calling out at me a little bit there, and that's the word static. Static's a really loaded term. I'm really kind of conscious of using the word static, especially when I'm thinking about static sites, because static doesn't always evoke the most kind of exciting image. It might feel like it's something a bit boring or a bit unwanted. And in fact, if we look at the dictionary definition of static, it actually says, lacking in movement, action, or change, especially in an undesirable or uninteresting way. Whew, I've got my work cut out for me if I'm talking about anything static here. But actually, I think of static as something quite different when it comes to sites. You know, when we talk about static sites, are we talking about a static experience, or are we talking about a static architecture that lends a site an experience of its own? In actual fact, I think of static when it comes to hosting sites as a huge virtue, and I want to try and convince you that that's the case before we go on to talk more about the other aspects of JAMstack sites. So let's look just for a moment at a kind of a classic comparison between a quote-unquote static site and a dynamic site when we think about their architecture. This might be, you know, an example of how a dynamic site is served. It's a bit of a simplification, but that's okay. Just for illustration purposes, we'll walk through this. Let's imagine a user is in their browser and they make a request for a view on a site. Maybe they're going via a CDN, but most likely in this first instance, they're hitting some kind of load balancer, and that load balancer will have some logic on it that we've determined, and it'll figure out, okay, which of the various web servers that we've got will service this request. Those web servers will have some logic on there themselves that says, well, okay, well, we need to render a view. We need to get some data for that. So we'll go off to one of our several database servers, get that data. That'll get returned to the web servers, compiled into some kind of view. We'll pass that back through the load balancer. Eventually, it'll get to a CDN. Hopefully, we'll cache some of that for subsequent views. Then we return that to the browser, and it's into the view and the eyeballs of our users. So there's a lot of different points there that we've got logic running, where we need to deploy code, where we need to maintain code, lots of moving parts. So if we compare that to a static site, what we have, similar scenario, you know, a user makes a request for a page, the request goes off to the CDN, which has the view, and it returns it, and we're done. Now, yes, this is far more simplistic, but there's huge benefits to having this particular scenario rather than having logic at all these different points. And I want to dig into that a little bit. Because you see, static means it's capable of being served directly from the CDN. Static also means an opportunity to reduce complexity. I don't know about you, but as a JavaScript developer and a front-end developer, I'm not too excited about configuring load balancers, figuring out how to deploy to lots of different web servers, making all of those things work together. Static is a real virtue as far as I'm concerned for reasons of simplicity. So you might reasonably ask, isn't this just a fancy new name for static sites? Well, okay, let's go a bit further. Let's talk about stacks themselves. Let's talk about another kind of popular, common tech stack when it comes to serving for the web. Let's talk about the LAMP stack. The LAMP stack, you may recall, is Apache. I'm mixing up the order just to throw you off the scent. It's Apache web server, which is, can you read that? Is that bright enough to read? Just about. I'll read it out. So the web server is doing the HTTP routing and the serving of some assets. We've got PHP, which is our preprocessor, which is unusual for me, the fact that it's called a pre-hypertext processor, because it's not doing anything ahead of time. It's doing it on demand. It's servicing requests, running the logic right there and then in order to service requests in real time. If we want to access some data layers, then we've got MySQL as part of that stack, and that all sits on top of a Linux distribution, which is our operating system. And this kind of combined is our LAMP stack for serving sites on the web. This lives on our web server. As we saw in that previous kind of illustration, chances are there are a bunch of those web servers because we need to manage load, we need to manage performance and all of those kind of things as our sites become inevitably hugely popular. We compare this to the JAMstack, and this looks a little bit different. Let's think about this in terms of taking it as read that we're serving these things from a static server. So we're not even thinking about the server itself in this instance. We're just assuming that we're serving files directly from a static server, or even better, from a CDN, a content delivery network. And that's the piece that we don't need to manage. That's something which, as a service, is handling our HTTP routing and the serving of the assets. But then into the stack that we're really concerned with, this has shifted. Now it's no longer in the server. Now it's moved closer to the browser. It's kind of taken a step up. And that stack is comprised of markup and JavaScript running in the browser. And indeed, the browser is becoming the most popular runtime on the web. That's where so much code can now execute, and we can do so much more than we might have done before. And if we want to access data, well, we can do that through APIs. We can do that to calls to external APIs that might be holding database servers. They might be doing all kinds of other services and facilities for us that we don't necessarily have to manage ourselves. So this stack is looking a little bit different. It's moved up a level, it's away from the server, it's a bit closer to the user themselves. So, the JAMstack is pre-rendered. We're building things ahead of time and then getting them to a CDN so they can get to a browser. They're served statically, so we don't have to perform any execution at request time on some kind of server. And they may be progressively enhanced. That's not to say that every JAMstack site needs to be a JavaScript application, but if we want to do logic, we've got the ability to do that in the runtime right there in the browser via JavaScript. So these are the kind of aspects of the JAMstack. Now, if we compare these two, as I say, the JAMstack has kind of moved up a level, up from the server and a bit closer to the browser. And this kind of means that, before, when we were serving things on the LAMP stack, we actually might have been dealing with all of these things, because the output, remember, of the LAMP stack was front-end code. That was probably markup and JavaScript and other assets as well. But here, we're kind of doing away with that and saying we're serving things statically and then doing our heavy lifting, if we have to, right there in the browser. So serving things in this way and deploying things in this way can really simplify deployments. And I'm all for that, because projects can get complicated. I want to look just for a moment at a typical kind of project timeline, from start to finish, where it starts with a brief and it ends inevitably with the awards, which is lovely. But we need to get from one to the other, and realistically, it's not perfect. There's no such thing as a perfect project timeline. For one thing, we haven't done any work yet. We'll probably have to start doing some work at some point. Before we collect those awards, we probably need to launch it. So knowing that we have to do that work, we figure out some scope. We work with the client, we define a scope, we understand what it is we're going to have to deliver, and then to make sure that we do deliver that, sometimes towards the end of the project, before launch, we get our final sign-off from the client that says, yes, thank you, that's what we were buying, off you go. So with those things in place, we need to know, of course, that there's going to be a review before that sign-off where we get to kind of talk about exactly what it is we've done. And so with those things in place, we start doing our work, we start building things, we're designing things, getting things out into some kind of environment where we can see them. After this has been running for a little while, we're feeling good about it, that's when we rescope with the client, because that's when they're starting to see things, so they change their minds inevitably, and we say, okay, here's our new scope. None of these dates have moved back yet, so we start working a little bit faster, a little bit more urgently. It's getting a bit more crunchy as we get to our client review. Then at the client review, we discover some new things, so we start working more and more frantically. Hopefully all of our processes are holding up. But this inevitably is when things start to get a bit panicky, and eventually there's a deploy which isn't quite where it should be. It's not exactly as it was intended. But that's fine. We can scramble. We can get back onto our perfect project timeline with our next deploy, where we get that onto, well, it's not exactly, again, where it should be, and in fact, it's not what it should look like. But this happens, at the sharp end of projects. Things get a little bit messy. Sometimes deploys don't look exactly as you'd intended from the very, very beginning. So, we scramble again. We get a few more things done before our final sign-off, and then we're at our final sign-off point with the client. We're happy, except it's not final sign-off, it's final sign-off. They've discovered some more things. So then we do a bit more work. We're scrambling for launch. We launch, we're ready for the awards, which we can get to after we've done a little bit more work to get our fixes done before. It's a shit show, is what I'm saying. Projects are difficult. Projects are hard under the best of circumstances. And when you get to launch day, it can be a bit like this. Has anyone ever sent a mass email out with MailChimp? This is their send the button to millions of people button, and it couldn't be more accurate. But this is what it can feel like to launch a project on the web, particularly when you've got infrastructure that's shifting, it's complicated, you've got deploys that you don't exactly know what they look like. I know that is a different piece of fruit, but that deploy is different every time we look at it. I don't know why. We've all been there. And the reason this is difficult is because each of these deploys isn't just a static thing very often. Sometimes there's a lot going on in each of these deploys. We might have this big monolithic architecture where we've got lots of pieces all bundled in together. They're on different servers, but they're all have to be really tightly coupled. It's a complex environment, so deploying this regularly, getting this out into the wild is difficult, and that's why we kind of end up in this situation. Doing each deploy when it gets to launch time, especially when it's a lot of code and a lot of infrastructure that we're getting out there, is it's a little bit nerve-wracking. It's probably fine. Oh, I'm sure the photographer of that was absolutely fine. Never mind the sharp bits of wood flying towards us. So given how complex that can be and how many moving parts there are, I'm super keen on finding ways to simplify, and simplifying the hosting infrastructure away from the pieces at the top where each deploy may have to touch all of this. This is just a delight to me, the fact that I'm just needing to get things to the CDN. And that's where things can change. When you focus on just directly building things and getting them to the CDN, this can unlock a lot of superpowers. So a bit of an admission. This isn't new. Of course, it's not. We've been talking about this for a while. Aaron Swartz did talk about the notion of baking, not frying. He was talking about how he'd architect his own content management system, saying that there's no point frying content up on demand for each visit to the site. He'd much rather bake things in advance. He kind of expanded on this and saying, I care about not having to maintain cranky AOL server, Postgres, and Oracle installs. And he said that in 2002. I couldn't agree more. That's why I love this kind of architecture. Now, getting things to a CDN, it's easy to say, but it's potentially quite difficult to do well. Thankfully, there are lots of companies that can help with this. One of them is where I work, Netlify, but there are others as well. So you may have heard of Surge, which is a tool to be able to run a command and rapidly deploy to their infrastructure, getting things directly to a CDN. Zeit have a product called Now, which does similar things. Or you can deal directly with cloud providers, such as Azure, AWS, Google Cloud. All of these ways of serving things directly from a CDN as static assets, and they come with some tooling along the way to help with that. So I want to just talk a tiny bit about what this model of pre-generating and getting things to a CDN might look like. There are lots of ways this could happen, but in its simplest form, we might be running a build locally where we run the build, it takes in things like content, templates, other bits of data, it munges those together through some kind of build process, and then we get a bunch of static assets that we can look at locally. We can look at on a static server, which is like a commodity on any of our local development environments. Seeing what that looks like, then we might want to push that to some hosting environment. And there are lots of ways we can do that through different APIs, through different tooling, to get things out to a hosting provider, such as the ones I just mentioned, who'll propagate it for us to a CDN. Now, this kind of architecture brings with it all kinds of impacts and opportunities, and I want to just talk about them just very briefly. Security being the first one. If you think back to that diagram we had of the two different stacks, a static hosted site or a JAMstack hosted site has a greatly reduced surface area. It's got far fewer vectors for attack, mostly because there are far fewer moving parts. If we think about the kind of attacks that happen on web infrastructure, they tend to depend on trying to influence that infrastructure by posting something to it and getting some kind of logic to run. At Netlify, we operate our own CDN, and a huge portion of the traffic to that CDN are bots trying to find WP admin URLs on all of our domains. They don't exist. There is no such thing on any of the sites that we created. Although I do know one or two users, one or two customers who put these on here and just to troll people. They don't do anything, but they like to send messages back to the bots. I don't think anyone's reading those. But being able to do away with this as an entry point just for WordPress sites, is a huge deal. But this is, of course, across all different types of sites. There is no moving part. There are no moving bits of architecture that you could attack in that way. In fact, the best kind of attack might be to do some kind of DDoS to actually try and hammer the servers to try and flood it with requests. But of course, if we're serving from a CDN by default, that's what those are designed for. That's what those are intended to solve. There are no bits of logic running behind the scenes that we're going to flood. It's purely serving static assets. And so when you can serve things from the edge directly in this kind of a way by leveraging a CDN, performance, scale, and security are just huge benefits that you get out of that. But I also want to talk about developer experience, and I'm cautious about doing that because I think we talk a lot about developer experience. We're very excited about the frameworks that we work in that give a lovely developer experience. But sometimes we're not quite so mindful about the user experience. And of course, developer experience is only really valuable if it's for the betterment of the user experience that comes out of it at the end. But I firmly believe that a better developer experience can yield a better user experience because there's so much friction that's out of our way. Particularly, I love to talk about deployment confidence. Knowing that a deployment is going to result in the right effects happening is huge. And so, a JAMstack site, since it's hosted statically, can far more easily have attributes like being immutable and atomic. Now, what do I mean by that? Well, when I'm talking about atomic deploys, I'm talking about a deployment which only goes live when all of the assets are actually there in the infrastructure. I don't know if anyone... Okay, let's have a little honesty test. Has anyone ever deployed a site over FTP? Yeah, okay. Oh, there's more honest people here than I thought. The rest of you, I'm squinting at you. I'm sure we don't do that anymore. That notion of dragging a file from one window to the other in FTP, I've experienced this at agencies in the past, where you do that, and then you'd go to the web browser, and you hit refresh and go, nope. And then you'd do another thing, and hopefully it would get there. This idea of having sites that are in an unknowable state because some of the assets are new and some of them aren't, that's not atomic. Having a deploy where all of the assets go to the environment, and only where they're all there and the integrity is correct do we say, okay, this is a viable deploy. Now we can toggle the traffic to go to that. That's an atomic deploy. Also, by virtue of these deploys being static assets that are served from a CDN, static hosting is really cheap. And so we can keep these deploys in perpetuity, which means that we can roll back from one to the other. An immutable deploy, of course, is something that doesn't mutate the state of the server. Each one is distinct, and it lives on in perpetuity, which means we can roll things back. I'm kind of nervously going to jump into a browser and just show you how easy that can be. Now, forgive me, I'm going to do this in Netlify, and I work at Netlify. I'm always very cautious about that. But similar tools exist in other environments, and what I'm trying to show you isn't the environment itself. Let me just see if I can turn off mirroring so I can see what I'm doing. Is this going to work? Yes. So it's not the UI that I'm trying to show off, but actually just the capability of being very easily able to revert to different deploys. So here is the deployment page for my own site. This is what my site looks like. It's a blog, nothing special or exciting there. But every deploy I've ever done lives in perpetuity down this page. You can see they've got different dates on them. Each one has its own URL. They live on in perpetuity. This one looks alarmingly similar to the last one, except it's maybe got different tweets or something in there. But the nice thing is that I could potentially, if I wanted to, turn back the time, right the way back to the beginning of. I don't know how brave I'm going to be here. Let's have a look. Let's go to this deployment. Let's preview it. Okay, so very radically different style there. It's 2016, and I'm still banging on about the JAMstack. I don't change the record very often. But this lives on, but if I wanted to change my current live site to that, what I could do is I could publish deploy. I'll publish that. And since these are immutable deploys that live at the CDN, now if I'm to go back to my site and reload, this is flushed now. The CDN cache has been flushed. I don't have to do that. I don't know about you, but I hate managing cache. It's just where I break things the most often. So knowing that these are static assets that can be served directly from a CDN, and a tool like this one, and again, others are available, can manage that cache for me, that's kind of liberating. That means that if I ever do a deployment and I want to revert it, I can do that very easily. And this is an entire site, kind of living on. I'm going to revert back to my real site now. I'm getting twitchy. The only people looking at this site, by the way, are in this room. I'm honest with myself about that. But let me go back to my most recent one, and let's see how quickly I can do it. So publish it, go back, refresh. Okay, and you can see that it's been reverted back to its previous state. Now, this is possible. Let me go back here. I'm just going to turn mirroring back off. This is possible, yes, because of the tooling, and the tooling is maturing, but also because we're serving static assets. And it means that doing a deployment doesn't mean deploying all the way through that technical stack. It's just changing something at the CDN level. Okay, that's fine. But static, again, as said at the very beginning of the session, that can feel a little bit cumbersome. It can feel a little bit tired at times. Well, we can go way beyond static, and the tooling is what's starting to help us go beyond static. Things like automation, which bring repeatability, predictability, and other things beginning with A, ities. This is really powerful. This is a huge enabler, and it enables all kinds of different developer experiences and kind of confidence. The other thing, of course, is replication. Knowing that we can do something repeatable in our local environment or in another environment, that's really important. I don't know how many people in the room have spent time provisioning a staging environment so that it looks exactly like the production environment, and then deploying something to that staging environment, and then promoting it to the production environment, and it not being the same, and you can't for the life of you figure out why. Having repeatable, identical environments is a huge key to success when it comes to building things predictably for the web. And in this scenario where we're talking about JAMstack sites, which are served directly from a CDN, all of the environments can live right there within the CDN directly. I want to talk a little bit about this notion of automation, because at the moment we've got this environment where we're running a build, we're looking at it statically, locally, and then we're just pushing that to a hosting environment. But how do we make sure that this is exactly the same with this if there are other influences at stake? And really what we want is our version control to reach all the way through to deployment. And so Git-based deployments can really help with that. Now, this is a model many people might be familiar with from tools like Heroku or from other continuous integration, but this is super powerful and super important. So in this scenario where we introduce version control to our deployment process, same thing's happening. Our build's running locally. We're getting our site that we can view. But then in order to get it to our hosting environment, we're not pushing the output of our build across to the hosting. What we're doing is we're checking our code into a Git repository, and then using continuous integration up in the hosting and the CI/CD environment. Every time there's a change to the Git repository, we'll pull that code, run the same build that we'd be running locally, have the same output that we then can propagate to the CDN. Now, this is a stepping stone into doing all kinds of interesting things. First of all, introducing different data sources. Because now, if we're starting to decouple things and maybe having data which is not just part of our code base, part of our local environment, we can do things like this, where this is the scenario we just painted out. But now, if we have somewhere that has content APIs, and this is part of the APIs part of JAMstack, this is a service provided by somewhere else, such as, for instance, a headless CMS. I don't know if people have encountered companies like Contentful or Sanity. There's a whole host of them that are hosting CMS UIs that output content APIs that you can consume. Well, if you do that and you decouple that in that way, it means that your static site, now when you run your build locally, you can be pulling the content from those content APIs and seeing the result locally. But then also, when things change, either if your code changes or if the content changes, that can actually trigger a build in our environment, our hosting environment, that will have the same effect. It will pull either the code changes or the content changes. Indeed, it will pull the latest of both. And then you'll have the same output in your hosting environment as you would locally. And this can consume data from all different kinds of places and can be triggered by all kinds of different things. So this is a way to increase our confidence in what we're building and deploying, and it's also a way to start to reduce some friction in our deployments. It should become trivial to do a deployment. It shouldn't be something that we're nervously building up to and then having a party afterwards because it went okay. I'm not against having parties, but it shouldn't be the cause for one necessarily. So when we deploy with low friction, it results in higher confidence in the project. That kind of dotted line we had before where we were nervously progressing, that can become a little bit more friction-free. And I want to just talk for a minute about a ridiculous example of automation built on the fact that we can run builds in a continuous integration environment at will just by triggering those builds that we looked at. And this example came from a slight bit of trolling from Zach Leatherman. Does anyone know Zach Leatherman, who does work on kind of font? I would definitely check him out. Like his font loading tactics are superb. So he tweeted this a while ago. He tweeted, "Freeside project idea, an HTML-only static site generated clock that deploys a new version every minute." And that's ridiculous. That's absurd. Of course, we know that that's not the way to do it. But when other people chime in and say, "Oh, that would be clever marketing for sure. Build so cheap you could set your clock by them." Okay, again, let's all calm down. Except I saw this and I thought, okay, could this be something that's wise to do, to generate a clock that's pre-generated and just deployed every minute? Thought about it for a while. I did say, only an idiot would make what you're suggesting. Here it is. And so this was kind of fun because, yes, it's a ridiculous example. And if you're starting to type this out and it's too long to type, you can just type find that.at/time, and it will just alias you through. And this was kind of a fun little example because it turned out, rendering, using a static site generator that all it does is it takes the server time and it flushes it out to a page. But we do that, 24 times because there's different time zones depending on where you are. And having a page for each one that, you can navigate to the time zone you're in should you wish to, or will route you directly. This is all fine, but doing it every minute, that's the kind of thing that you can do with a tool like this. So this is webtask.io, which will run a serverless function for you for free, and you can do things like set a cron job, so it will call a web task every minute, a serverless function every minute. Now, it turns out that the same kind of build automation that I was talking about earlier on can be triggered by a webhook. And so if we have a web task that every minute calls a webhook which runs that build, it's run now 341,661 times since I deployed it. That's 341,661 deploys. Most of them, pretty much all of them, haven't been while I've been sitting nervously watching, which is what I always used to do with my previous roles deploying large infrastructure. Now, don't do this. This is silly. Of course it is. Deploying a site every minute's ridiculous. But the point I want to prove is that the friction to deploying can be so low and the confidence can be so high that realistically you can trigger things at will and just not be monitoring them as they deploy. This is kind of a big part of the JAMstack ecosystem, these kind of services that can execute things based on webhooks and can work on build automation. So I want to talk about a couple of different examples and results. Sites that are hosted this way that maybe you wouldn't expect. Well, there are some that are kind of obvious that they fit this model. Documentation sites. Sites like React.js, this is a JAMstack site. It's hosted statically, although it does have search, because there are lots of search facilities now that we used to think, we need something on the server to be able to run a search. Actually, there are lots of services such as Algolia, as a prime example of being able to do very sophisticated search via an API directly into your browser. And there are some nice fallbacks for this as well. So sites like this are living on a JAMstack. Another example, similar kind of example. These are all living as JAMstack sites. Yarn, a bunch of these are JAMstack sites, receiving a very large audience, but being able to kind of weather that audience with fairly minimal infrastructure costs because they're served statically. One that might feel a bit less obvious is something like Smashing Magazine. So do many people know Smashing Magazine in the room? Just show of hands. Yeah, got a bunch of you. So it's a big publishing platform that talks about web development and design techniques. And this used to live on a bunch of different platforms. It used to run itself on WordPress, but there's a job board that ran on a different platform. There was an event site that ran on a different platform. There was a commenting tool, lots of different platforms. And we did a project with Smashing Magazine a couple of years ago to move across to a purely pre-generated, statically hosted infrastructure. And Vitaly, who was the editor-in-chief at the time, he was describing the environment they used to have, and he was saying, we had some caching issues with probably every single WordPress caching plugin out there, because there are a lot of them. There are a lot of kind of things you can try to dial up to manage caching for you. But ultimately, these are all sitting in front of lots of moving parts, and that's where things get difficult. Smashing Magazine at the time was having about 2.5 million visitors each month, so it's a non-trivial amount of traffic. And through doing this, they moved from having 5 different technical platforms at request time down to 1, because everything was pre-generated and deployed to a CDN. And the performance increase was kind of remarkable. So it was a 10x time to first load of most of their pages, moving from 800 milliseconds down to 80 milliseconds. Before the project even began, we did an experiment where we just simply dumped out a load of their pages, captured those as static assets, and served them directly from a CDN. And we saw a 6 times increase in performance just by doing that, just by baking things out statically and then serving them from a CDN. But then when you get to the point that you're able to start to architect the front end a little bit differently and know that everything's going to be hitting a CDN directly, you can tune this even more. Now, a different type of site, for instance, was this, which was released at Google I/O just a couple of days ago. So the Google Chrome team built this as an experiment. So I do apologize. This is Minesweeper, and I realized a few minutes ago I didn't have a video of it. So I videoed me. This is agony watching me try to play Minesweeper while listening to the previous talk. It's like, what are you doing? What are you doing? This is pretty awful. Oh, that's clearly not okay, never mind. But the point is that this is it's a relatively simple but still kind of interactive game running in the browser. The browsers can do so much these days, but there's no server behind this. This is just running entirely client-side. And this has been architected to be really performant. The payload to interactive is just 25K, and then there's progressive loading of some of the other assets after that. The time to interactive on a slow 3G connection is under 5 seconds, and it's very backward compatible even to feature phones. There's a lot going on there, and it was launched with a fair amount of attention, but since it was all hosted statically, there was no server to melt down. It was served directly from a CDN. So a lot of things were just able to be much smoother and perform well. But those are two very different types of sites, one of them that potentially could have no JavaScript and some which are very JavaScript heavy, both of which I'd classify as being a JAMstack site because they're served without an origin server directly from the CDN. I want to talk about JavaScript just for a second. As I mentioned, a JAMstack site doesn't have to depend on JavaScript. I think the fact that JAMstack starts with a J, that's maybe that could be a bit misleading. But I think of it more as an opportunity to use should we want to. When I was building LampStack sites, I didn't always have a database behind those, but I still consider those to be LampStack sites. I wouldn't change the name depending on whether I had a database or not. And so it is with JAMstack sites as well. We don't need to think that we have to pursue this approach of putting everything into JavaScript and just shipping markup, which is just an empty body tag, and then everything happens in the browser through JavaScript. We absolutely can do that if we need to. And things like that game that we just saw is probably a fairly good example of potentially times we want to do that. But Alex Russell, his name popped up earlier today already. A couple of years ago at the Chrome Dev Summit in San Francisco, he was very, very passionate about ways that we could make our sites perform better, particularly in different environments and in challenging environments. And I'm nervous about putting a slide like this up at the International JavaScript Conference that we're at, ship less JavaScript. But being mindful about how much JavaScript we actually ship down to the client is really important. There's some quote somewhere about more power and more responsibility. And that's really the world we're living in at the moment. The frameworks that we can use are incredibly powerful and they're incredibly tempting, but using them wisely is really important. And I know that there are lots of sessions today about exactly that. So the JAMstack isn't about making everything run with JavaScript. It's about pre-rendering as much as possible to remove the need for an origin server so we can simplify the hosting architecture. It's about progressive enhancement to enrich the experience with JavaScript through services and APIs. And it's more about that than pushing everything into JavaScript, although JavaScript is the runtime of the web that we can leverage should we need to. But there are other ways we can augment JAMstack sites as well, because sometimes you absolutely positively need just a tiny bit of logic on a server. I'd like to be able to say that everything could just be served statically and there never needs to be anything on a server. But the truth is, even if we're doing things like making a request to APIs, sometimes you don't want some of that information in the client. Sometimes you just need something to proxy a request so you can include things like an API key that you wouldn't want to be sent in the clear from the client. And luckily, there are tools that can help us do that. That's where serverless can come to the rescue. We talked about serverless in the panel at the very start of the day, and I'm nervous about just using the word serverless because I know someone's itching to say, there's a server. And I think about it in the same way I think about my Wi-Fi at home. I've got a wireless router. I know there's a wire in there somewhere, and that's fine. So I like to think of serverless more as functions as a service. Functions as a service, is something that can really enable a microservices architecture where we start to offset some of the code that we might want to run ourselves and push that elsewhere. it kind of lowers the overhead of deploying, maintaining, and managing and securing our code because we don't need to deal with the infrastructure behind it. Many people will recognize this as kind of the classic kind of signature of a basic serverless function. And I don't want to really talk about the code of it, but just knowing that we can shift the burden from infrastructure that we would manage onto something that can be managed for us by one of numerous providers, where they'll all look after the software and the patches for us. They'll deal with the operating system. They'll deal with the network. They'll even deal with the physical and virtual scaling of these things, so we don't need to worry about it. That's hugely liberating. When we think about how we might be able to employ the expertise of others, the kind of large monolithic application that we had in the past, we can start to find things that we can abstract and push those out to serverless functions. And in this way, by breaking apart this kind of monolithic view, we can enjoy both bought services and built services that we've created ourselves by specialist teams. And this is nice because it means that our services can just have a single job. And when you've got one job, you can just do it really well. I know that that's not a guarantee. Just having one job doesn't mean that you're always going to nail it. But it means that you do have a much smaller kind of surface area to reason about. Now, these kind of things can be glued together really nicely with things like events, webhooks I mentioned earlier on, these microservices and APIs. They can all provide this glue that can build these fairly complex systems where we don't have to deal with large amounts of the complexity. So when we think about services, there are different types of services. So bought services, things that might be the specialism of other companies. I mentioned Contentful as a content management system earlier on, and there are a few others. We might be thinking about calling on the services of an asset provider, where we can push our assets. They can do manipulation, optimization, serving of those through their own services. There might be commerce layers that we can add onto the top of this. Stripe, Snipcart are a couple of good examples of services where you can add e-commerce capabilities directly into your browser through their APIs. And there is more. There's things like identity by using things like Auth0 or OAuth, all of which are available through APIs into the browser. But what of the risk? Some skeptics might think, well, this is fine, but we're pushing all of our capabilities off to the hands of other companies. Are we comfortable with that? Well, I'm really very risk averse. To the point that, the nickname that I had at an agency where I worked was the Dream Crusher, because, at the point that the technical architect has to come in and figure out if we can do something or not, I was always very, very skeptical. And this, in fact, is an illustration of me crushing the dream of this particular creative director. He was so adamant that I was the Dream Crusher that he illustrated this. In fact, he illustrated me as the superhero, the Dream Crusher. If you look closely, my clasp is the Dream Crushing clasp that looks like this. He did a whole brand identity. I had quite the reputation for dismissing things that might be a bit too adventurous. But that's by the by. None of us really want to be the Dream Crusher, but we have to sometimes be a little bit cautious, a little bit risk averse. And so, even me, I'm very happy to offset this kind of capability to an external party, because vendors who provide just a single service, whose business depends entirely on that service, they depend on that success more than you do. If they can't provide that service, they're just simply going to go away. And if they could do that one thing and do it really well, then they can provide that service with a level of certainty. We can have things like service level agreements and technical contracts, all those kind of things. So I'm comfortable with that level of risk. But then if we also think of the other kind of services that we can access through microservices, it's our own in-house built services as well, things that we build in-house. Because yes, these are all bought, but we might want to add some of our own flavors as well. And that's when we can start to use things like functions as a service to build single capabilities that we don't have to host infrastructure for at all. So this kind of smaller surface area is easier to reason about, and it creates far greater agility. It creates a better focus, which gives us a quicker path to MVP, this minimum viable product. And I just want to pause just for a second to talk about MVP and talk about the importance of MVP, because I've heard some skepticism about MVP in the past. In fact, I went to a conference a couple of years ago where someone was on stage saying MVP is the enemy of excellence. You know, it's the devil. And they're saying, I wouldn't use a minimum viable parachute. And I thought about that for a little while. And I thought about a time where I would need a parachute. And I thought, I fucking would, I'd be honest. When it's a choice between a parachute that's there, but it hasn't had the right branding, and it hasn't been through the last stages of testing, or no parachute, I'd rather have the parachute. Because sometimes we think of it being the enemy of the good, but MVP is not choosing a weak product over a good product. It's about choosing something now and then something better later. It's a tangent. I'm sorry. It bothers me, this kind of notion. So I've talked about a bunch of things, and I'm almost at time, but I just want to give a quick example about webhooks and serverless functions and automation, because when you start to glue these things together, you can do all kinds of things that don't feel like a static site. And for this, I'm going to nervously jump across to my browser again. Oops, am I? Am I going to nervously jump across to my browser again? Let me unmirror so I can see what I'm doing. And so, let's see. Kill a few of these things. Oops. Find that dot at comments. So what I have here that I'm fumbling to show you is a comments engine, which is built as a static site. Now, there's lots of services that can help you add comments. There's things like Discuss, which is a JavaScript drop-in to do that. But I don't care for doing that. I like the content to live in my site. So in this particular site, what we have is it's basically just a blog site with a bunch of comments in there. Now, these comments, it's very hard to see at this size and this darkness. These comments are baked into the HTML. And what I'm going to do is I'm going to add another comment myself here. That's my name. Hello, scary room. And I'll post that. Now, what's happening in the background is that's been posted to an API, and that API has triggered an event that calls a webhook, which is a serverless function. That serverless function pokes a notification to my Slack. I'm very brave, I think you'll agree, showing you my Slack channels. And here's the notification that says, okay, hello, scary room. And I've got a couple of options. I can either delete it or approve it. If I was to delete it, that would remove that comment from the API, the bucket that it's sitting in. If I approve it, it'll move it across to another bucket and fire another webhook. So if I do that, what that's doing is going to move that across into another part of the API, and it's going to fire another webhook that says, okay, run a build. And the build, if you recall earlier on when we abstract the content out, the build can pull the content in, generate the site, and we end up with a moderation tool, live comments on a blog with no JavaScript at the front end that we can moderate live. So let's see, I don't even remember which page I was on when I did that. I was on no performance bottlenecks. So let's see if that has actually come through. Hello, scary room. So we're starting to stitch together a lot of different systems, a lot of different tools. But the nice thing is that since every one of these is very discrete and doesn't have lots of moving parts, we can be confident in every single one of those things, which creates for a nice, robust system. Okay, we're out of time. I'm wrapping up. So, at the very beginning, I asked, what is the JAMstack? And just to kind of reiterate, JAMstack sites are rendered in advance. They're not dependent on an origin server, which is one of the really liberating things about them. And if you need to, they're progressively enhanced in the browser with JavaScript. Do we need it? Again, the other question we kind of started with. Well, I'd say that JAMstack brings kind of reduced infrastructure costs. It's improved security, performance, and scalability because of that simplicity that we've got. And it can bring much greater confidence in the life cycle of a development project. A bunch of things that I've glossed over quite quickly, I've added links to at the end of these slides. this is really bad form. You never tout one conference while at the other. But if you're interested in learning more about JAMstack, there is a JAMstack conference in London on the 9th of 10th of July. You can find that at Conf. All of the links and all of the examples I've got here will be in my slides, which are published and they're online now, and you can find that at JAMstack. I'm just a moment over time. Apologies for that. Thanks very much for listening. Thanks a lot.